Hello, I'm Thomas Anderson, also known as 40286605, and did you know that there are some metals that seem to disobey the laws of physics? These are superconductors, and they only seem to disobey the laws of physics. These metals can hover in place, but it's not magic, it's entropy. For starters, what's entropy? Entropy is a concept that describes the order, or perhaps the disorder, of the universe. When molecules or objects have low entropy, they are ordered neatly. When the same molecules are said to have high entropy, that means they are highly disordered and random. On a large scale, you can think about your bedroom after you've just cleaned it as being in a state of low entropy, whereas you leave your bedroom, start to get clutter, and then it becomes a state of high entropy, which happens to be the state of my room right now. I got comic books and all sorts of stuff all over the floor. So I'm a very good example of high entropy. So this is all because matter actually increases in entropy with time, and that's a law of physics. This is due to the nature of time, if you want to get into that, simply being an expansion of space. Or at least that's what leading physicists think of it as. Anywho, it's the same thing where, like, if you were to knock a cup off your table, the cup would shatter into a bunch of pieces. Only if you were to reverse time would you see cups jumping up onto tables and putting themselves back together, which doesn't happen because entropy travels in one direction. Now, I think we must first understand the concept of resistance before we discuss how superconductivity has to do with thermodynamics, what it has to do with it. Resistance in a metal is a value that affects the flow of electrons through the metal. A good conductor has low resistance. The flow of electrons is distributed due to random scattering. The flow of electrons is disturbed, due to a random scattering of electrons within the metal. A scattering that occurs due to vibrations of the atoms, and this is effectively resistance. It's the atoms vibrating within the metal. Now, as we lower the temperature, we know that atoms vibrate less, causing less random scattering of electrons, and therefore less resistance. Superconductivity itself occurs below a critical temperature at which the electrons turn into a type of boson called a Cooper pair. A characteristic of bosons is that they disobey the Pauli exclusion principle, meaning they can only occupy one certain energy level, and they all the electrons within this material can occupy that same energy level orbital, which otherwise wouldn't be allowed. So they're actually trapped within this orbital, meaning that they can't be disturbed or excited to higher or lower states. And now this means the atoms are extremely ordered because they can't be disturbed by the random scattering of electrons disturbing the lattice. And this causes zero resistance, and this is in essence superconductivity. Now thermodynamically, this is exactly what we would expect to happen. We lower the temperature and we get less random scattering. That's what we would expect to happen given the third law, which states that as you approach absolute zero, the lowest possible temperature, which is only theoretical, entropy approaches zero. And this is reflected in superconductivity. The colder we make our metal, the less entropy it has, and the less random scattering of electrons occurs, allowing it to achieve a state of superconductivity. Now, back to why this makes things float. I don't want to get too deep into the E&M, but essentially, superconductivity, it causes the Meissner effect, which is a complete rejection of internal flux due to surface currents on the metal. So essentially, currents develop, which cancels out the internal flux. And that creates a perfect diamagnetism with the field. So the magnetic fields of the metal perfectly cancel out with any opposing fields, which is why if you have a magnet and you place a superconductor on top of it, it's effectively held into place. The diamagnetism prevents it from moving. It's sort of stuck. So it's really neat stuff. And it's all caused by the third law of thermodynamics, the lowering of temperatures causing less movement of electrons. Now, for more information on superconductivity, I recommend looking into how MRI machines use this fascinating principle for medical imaging. Thank you very much for your time.